Hello everybody, in this video we're going to directly build off of what we did last class. Last class we talked about rates of change, but we did them with a graph and a table. Today we're going to do rates of change, but this time with word problems. It's going to work exactly the same. We're going to use coordinates to find the slope of a line, and slope is the same thing as the rate of change. The rate of change and the slope are the same thing, and it's just that the slope is more of a straight connection to graphs, and the rate of change is a straight connection to real world problems. Whenever you're going to the store, whenever you're driving your car, those situations have to do with rates of change. But if you're just looking at a graph or you're looking at a hill, you can see the slope of that hill or how that graph is changing. The difference for this is we are going to include the units as we do our division step. Here's an example for you to read and go through if you want to, but I'm going to go through a couple examples also. I'm going to do number 2. At 3 o'clock you were at mile marker 295. At 6 o'clock you passed mile marker 475. If you don't drive, then you might not know about mile markers, but if you're on a road, they just use those markers. If you get in an accident on a highway in the middle of nowhere, you could tell them what mile marker you're at, and then they'll find you. We need to turn this situation into a coordinate. One spot would be, the x would be 3 o'clock. At 3 o'clock, you were at, on this highway, mile 295. And at 6 o'clock, the mile marker you're at was 475. So if we're finding the average rate of change, we are finding the delta y divided by the delta x. How did the y's change and how did the x's change from those 2 points? To find that out, we do the second number minus the first number. We do that for the y's, 475 minus 295, and those are both miles, and we're going to divide by the x's. We ended at 6 hours, so we're going to put 6 first, and then we're going to subtract the start from it, and these are hours. Then we're going to simplify and then divide. 475 minus 295 is going to be 180. Oh, that's going to be 180 miles that you traveled. 6 minus 3 is 3 hours. And then we just reduce this. 180 divided by 3 is 60 miles per hour. And just so that we know 100% sure, that means per 1 hour. 60 miles every 1 hour that passes. That was her average rate of change. So now we just need to answer that back in a sentence. The other requirement besides finding the slope was to write a sentence interpreting the slope with the units in that answer. So our answer was m equals 60 miles for 1 hour. Now we just need to turn that into a sentence. What's her name? Her name is Sharon. Drove at an average rate of Sharon drove at an average rate of 60 miles per hour, period. One more thing about this average rate thing. You need to say that it's an average rate because we don't know if that was her actual speed. It could be that she floored it sometimes and was going 100 miles an hour, but then overall she might have had to slow down for something, or maybe she stopped and took a restroom break while she was going 180 miles total, and her average speed was 60 miles per hour. She could have gone faster than that sometimes, and she could have gone slower than that, but on average, it evened out to 60 miles per hour. Let's do this number 4. We have a person in a lab growing bacteria. At 1 hour, there are 250 bacteria. After 3 hours, okay, so they both say after, so that means we can just put the number 1 and 250, 1 hour and 250 bacteria, and then 3 hours, there are 1,000 bacteria. Let's find the delta y divided by the delta x. The y's are the bacteria. We had 1,000 at the end, and we're going to subtract 250 to find the change between those two. What was the difference between those numbers? Then we take 3 and subtract 1, and that's going to tell us the change between the x's. The top ones will subtract and be 750 bacteria, and 3 minus 1 is 2 hours. This means that when we divide these numbers, we're going to get, let's see, half of 700 is 350, and then half of 50 is 25, so we'll add 350 and 25 together to get 375 bacteria per hour is the average. Maybe sometimes these bacteria are multiplying faster than that. Maybe sometimes they're going slower than that. In fact, they definitely are, because that's how growth happens. It's not one speed, it's not one linear speed, but we can average it as that. Now let's just say this back as a sentence. I'll use a different color. The bacteria reproduced at a rate of 375 bacteria per hour. Seems easy enough, right? Let's do one last one. I showed you how to do a table yesterday, so you should be able to do those. I guess I'll do this one about somebody typing a paper. The starting time. Okay, he's not typing it, he's printing it. He started printing at 3:15. So he started printing at 3:15. That's the time. And we might have to change that time to hours or minutes later. When he started printing, that's 0 pages. Once 5 minutes have passed, at 3:20, he had 120 pages. Let's just find the change in the y's, and maybe we can skip a step here. The difference between 0 and 120 is 120 pages. Because if you subtract 0, that's not going to change anything. Now let's find the delta x from 3:15 to 3:20. From 3 o'clock and 15 minutes to 3 o'clock and 20 minutes, that's only a 5-minute difference. Now let's reduce this to find how many pages per minute he's printing. 5 fits into 12 2 times. That would leave a 2 as the remainder. 5 fits into 20 4 times, and that's going to make 24 pages per 1 minute. So this means the sentence would be Scott's paper printed at a rate of 24 pages a minute. Oh, at an average rate. Once again, it's important to say average because it's possible that some printers take some time to warm up at the start, so they wouldn't be printing as fast. And then once they get their ink all hot and ready to spray on the paper, then it goes nice and fast to get that 24 pages per minute. Okay, I'm going to leave the rest to you. That should be about 12 questions. Yes, 12 questions that you'll have to do today. If you have any questions, come to the live session at 2 o'clock on Monday, October 5th, I think, and I'll help you out.